Hello, all of you. My voice is audible.
Yes, sir.
Okay. So yesterday I've given you 5 questions. So everyone has completed this. Atif, Huzafa, Mazia, do you have tried these questions? Silence means no. Okay, but no issue. These are important questions. So we will do this in today's class. But please try to try to do the homework, okay? Because it is not possible for us to do all the questions in the class. Okay, so I'm not sure from where I have started. This 7th question, this have given you in the homework? Atif, Zafar, Mazia, are given this question? Sorry, yes or no? Please reply.
Yes, sir. Give us this comment.
I have given this in homework. Okay, so please check this question. In this question, they're saying that show that the relation R on the set A of points in a plane given by R is equal to PQ. Okay, distance, show that the relation R on the set A. What is the set A? It's a points in a plane. So set is given, which is points in a plane. Given by, this is your relation R. Relation is R is equal to PQ. Okay, this is the ordered pair. And what is the relation? The relation is distance of the P from the origin. Distance of the P from the origin is same as the distance of the point Q from the origin. So they have taken 2 points, P and Q. Okay, they have taken 2 points P and Q from the set A. And the condition is that the distance of point P from the origin should be equal to the distance of Q from the origin is an equivalence relation. Okay, second part we will see later on. So first of all, you need to prove that this is an equivalence relation. Okay, we will check this. So for reflexive, we have done many questions. So you know this, that we need to first of all assume the points. Okay, for reflexive. What we need to do for reflexive, let P belongs to and what is the set? Set A. Let P belongs to set A. What is the set A? It is a set of all the points. Okay. So set A is set of all the points in a plane. So you know that in a plane, the point is denoted by x comma y normally. Okay. Or we can say we have 2 elements here. For example, x comma y. So point will be taken like this. So if we are assuming a point P, so P means like this, x comma y. So that means, for example, 1 comma 2. So we are assuming like this. So here we have, I've written that let P belongs to A. Okay, now what we need to prove that P comma P should belongs to R. P comma P belongs to R. Now let P belongs to A. Now can we say this, that distance of point P, distance of point P from the origin is equal to from the origin from the origin is equal to the distance of point P from the origin is equal to the distance of point P from the origin. Okay. What does this mean? This means that distance OP, O means from the origin, OQ. Okay. We will write here O is the origin. Who is the origin? And no, this is not OQ. I'm sorry. Okay. For reflexive, what we need to show that OP is equal to OP. For reflexive, what we need to show this one. P comma P belongs to relation R. What is mean by P comma P? P comma P means distance from the origin, distance of origin from point P is equal to distance of origin from point P. So we know this, that this is equal. We just need to represent our answer. Okay, what is reflexive in this case? Reflexive is there should be a same point. So that means they have given point P comma Q, we need P comma P. What is mean by P comma P? Distance of point P from the origin. So that means OP is equal to OP. Okay, so this means, this implies P comma P belongs to relation R, hence relation R is, hence relation R is reflexive. Okay, they have given us P comma Q, but for reflexive, what we need P comma P. What is mean by P comma P? P here, what this P represent? Distance of the point P from the origin. What this Q represent? Distance of point Q from the origin. So here we have used the same point, P and P. So this, we know this, that distance from the origin of the point P is equal to distance of the origin from point P, but we need to represent our answer like this. This is clear, Atif, Huzaifa and Mazia.
Yes, sir.
Huzaifa and Mazia, this is clear? Okay, Mazia. Huzaifa. Okay, so please do the homework for this chapter. Okay, because you need to do the practice at how you have to represent your answer. You know that this is a equivalence relation. There's a very simple question, but how you need to represent your answer, for that you please do the practice. Okay, this is done. Shall we start next? Symmetric. Shall we start next? Please raise your hands. In the participant, you can raise your hands. Okay, if this is done. Okay, Atif Huzaifa. Okay, Mazia, shall we start next? Mazia. Okay. So I'm sorry, I don't have the space. Okay, so I'm using the next page. Okay, this is, we are not doing this question right now. Okay, so for the previous one, we need to check the symmetric. Symmetric. We have done many questions. Okay, so who can tell me? Atif. Atif, please tell me what we need to assume first.
Let 2 points P and Q belong to A and PQ belong to R.
Very good. Let P comma Q, sorry, P comma Q belongs to A. Okay, we have 2 points P and Q. This belongs to set A. Such that now we are taking this ordered pair such that P comma Q belongs to R. Okay, but before we will do the proof of this, we should know that what the answer we need. Okay, so in the starting only, you must know that what you need, and at the end. Please don't expect that while you are doing the proof of any question, at the end you will get the clear answer. First, you know the answer, then you need to represent that. So we have assumed this one such that P comma Q belongs to R. So Atif, will you please let us know that what the answer at the end we need for symmetric?
What is it? Can you repeat?
Yeah, I'm saying that here we have assumed that P comma Q belongs to R, but in the end, what we need, what we have to prove now.
Q comma P belongs to R.
Yes, very good. Okay, so Huzaifa and Mazia, please check here. In the starting of the question, you must know that what we need at the end. We need this one. We have to prove that Q comma P belongs to R. Okay. Okay, so what is mean by this? Who will tell me? Huzaifa. Huzaifa, What is mean by this? P comma Q belongs to R. This is almost the last topic of this relation. So if anyone have a doubt, then please let me know. Okay. Josefa, please tell me what is mean by this P comma Q belongs to R? Yes, P and Q belongs to R. So that means what? Distance of point P, distance of point P from the origin is equal to distance of Q from the origin. Distance of Q from the origin. Okay, Noma, you were absent yesterday. So yesterday we were just doing the questions of relations. Okay. And we have started the definition of function. We have done the portion which is there in class 11. So I will just show you that right now I have given these questions in homework, but we are again discussing these questions. So if you wish, you can take a screenshot of this, Noma. Okay. Please let me know, Noma, once it is done. Okay, Noma, very good. So I will explain you the question. What's the question? We have a set A. What is the set A? Points in a plane. Okay. Next, we have this one. Distance of point P from the origin. This is the relation P comma Q. What P comma Q represent? Distance of point P from the origin is equal to the distance of the point Q from the origin. So this is the relation. Okay. So we have proved this reflexive, Noma. So I will explain you this later on. Right now we are doing the symmetric. So for symmetric, you know that first of all, from the set, we assume two elements. Here, in place of elements, we have a point PQ. So we have assumed that P comma Q belongs to A such that P comma Q belongs to R. Now, what is meant by this relation? The distance of point P from the origin. So we can represent this like this, OP is equal to OQ. Now we can also say that if OP is equal to OQ, then OQ is equal to OP. This is the same thing. So this implies if OQ is equal to OP, then as per our relation, this means what? Q comma P belongs to R. Okay, OQ is equal to OP means the first point will become Q and this P will become the second point. So Q comma P belongs to R. Now here, so we can say this P comma Q belongs to R. Okay, this implies this belongs to R. This implies Q comma Q also belongs to R. Hence, relation R is symmetric. Okay, we are in this line we have just written the same point that this belongs to R. This implies Q comma P belongs to R. Hence, this relation R is symmetric. Okay, please raise your hand if this is clear. Atif, Huzefa, Masiya, Numa. Okay, Atif, okay, Huzefa. Mazia and Noma, this is clear? Okay, Noma, very good. Okay, Mazia, very good. Okay, so we have taken a lot of time in this chapter, but inverse we will complete in 2 classes, hopefully. Okay, so please note down this, confirm me, then we will do the transitive. Noma, you were absent yesterday. How many chapters you have completed in your school? Noma, how many chapters you have completed? Yes, Noma. Everyone in the meantime, please note down this, okay? And raise your hand if this is done, then we will do the transitive also. 3, 4, okay, 1, 2, 3, and 4. So relation and functions we have done inverse. So we have completed 2 chapters. Okay, Noma, no issue. Hopefully till next Saturday, we will complete a relation and function. Okay. Okay, so this is done. Okay, Atif. Huzefa, Mazi, and Uma, please raise your hand if this is done. Then we will do the transitive also. Okay, Mazi, very good. Okay, Huzefa and Uma, good. Okay, then I will rub this and we will start the transitive. Okay, we are not doing this question. We are doing transitive. Okay. Third part is transitive. Okay. Now, in transitive, what we always do, we take 3 points. So let P, comma Q. We can take R, but R is a relation, so we might get confused. So we can take any other symbol like S. PQS belongs to A, such that you will always repeat the same step in every question, such that P, comma Q belongs to R and Q, comma S belongs to R. Okay, we have assumed 3 points in this set A, such that P, comma belongs to R and Q, comma S belongs to R. This implies from this relation we will get this OP is equal to OQ, and from this this is one, and from next one we can say OQ is equal to OS. This is second. Now from 1 and 2, what we can say, OP is equal to OQ, OQ is equal to OS. So from 1 and 2 we can say OP is equal to OS. Okay, so from 1 and 2 we can say OP is equal to OS. So this implies P, comma S belongs to R. Thus, so we will repeat the same thing. P, comma Q belongs to R and Q, comma S belongs to R. This implies P, comma S belongs to R. Hence, relation R is transitive. Hence, relation R is transitive. Okay. So I hope this is clear to everyone. Please note down this. And raise your hand if once this is done, then we will do the second part. Okay, Atif, very good. Josefa, Mazia, and Omar, please confirm. Okay, Josefa, good. Okay, Noma, very good. Mazia, this is done. Okay, very good. Okay, okay, Noma, so you have missed the reflexive part. So in reflexive, what we have done, we have just proved that P, comma P belongs to R. So what is mean by P, comma P? That OP is equal to OP. So if you have taken the screenshot, you will check in that. So we have just written this point that OP is equal to OP. But the same thing we have also written in words, that distance of P from the origin is equal to distance of P from the origin. Okay, that's why it is reflexive. This is clear, Mama? This point is for reflexive, this clear? Okay, very good. Now the next part. In the next part, they are saying further show that the set of all the points related to a point this. They are saying show that set of all the points related to this point. This point is not origin. Okay, what they have done, they have fixed one point P, and they're saying this point is not the origin. And they're saying set of all the points related to this point P is the circle passing through P with origin as the center. Okay, so what does this mean? Just give me a minute. So what does this mean? You have a origin here. You have this origin. They have assumed that there is a point P. Now they are saying that, or show that they are saying that set of all the points which are related with P. Okay, what is a P? This is origin. So they are saying that all the points which are related with P is the circle passing through P with origin as the center. They are saying they are saying all the points which are related with P will form a circle which will pass through the P, and origin will be the center. So if we will check this definition, PQ, they are saying distance of point P from the origin is the same as the distance of Q from the origin. So if this is a point P, you will assume a point, suppose the distance between the origin and the point P is 2 units. You will assume any other point, for example, this one Q. You will find this distance, this is 2. You will assume next points, for example, this one. The distance is again 2. So you will select all the points such that their distance from the origin will always be equal to 2. Hence, they will always form a circle. Because if the distance is fixed, so that means that will become the radius of the circle. Okay, how to represent our answer? We will represent like this. Let P is a, let P is, just give. Let P is not equal to origin is a fixed point, is a fixed point. We have fixed this point P is a fixed point. Let Q be a point in a plane, Q be a point in a plane, such that PQ belongs to R. We have assumed a point in the plane such that PQ belongs to R. So what does this mean? This means OP is equal to OQ. Okay. Now, so if this Q point is not fixed, we have assume a general point in a plane. Okay, so this, we can say this represents set of all the points. So if we will select all the points whose distance from the origin is equal to OP, then this implies locus, or we'll write a general definition. This implies set of all the points, whose distance from the origin, is equal to the distance of point P from the origin, represent a circle. Okay, represent a circle whose center is origin, and passes through P, Okay, so I hope this is clear to everyone, that we have fixed the point P, we have taken a point Q, which represents set of all the points. If these set of all the points have the distance from the origin is equal to OP, then this will definitely represent a circle. Okay, so please note down this. We still need to do rest 4 questions. Please note down this one. And raise your hand once it is done. Okay, Atif, very good. Noma, Huzefa, Maziha, this is done. Please raise your hand. Okay, Noma, very good. Huzefa, okay. Maziha, this is done. Maziha, this is done. Shall we start next? Okay, very, very good. Okay, so Rishan, you have just joined. So I'm going to start a new question. Please check here. Okay, so this is a very important question because this is a very different type and we have not done such type ever before. Now, and this question also came in CBSE 2010. Okay, this type is very important. Uh, okay, so what is the question? Prove that the relation R on the set n cross n. What the set is given? N cross n. Defined by this is the relation. Okay, so first we need to understood that why they have taken two ordered pair. If we will check up this question, okay, if we will check here, then we have a single set. Check here, we have a single set A here, and they have taken just a single ordered pair. In the relation, they have taken a single ordered pair, and here they have taken just a single set. But now in this question, they have taken not a n. They have not taken n as a set. They have taken n by n. Can anyone tell me the difference between this question number 8 and this question? Why they have taken n cross n?
That's the same thing, right?
No, this is not the same thing. N cross n means Cartesian product. Okay, Atif, we have done the Cartesian product. N cross n means Cartesian product. N cross n always give you what? A Cartesian product. So in place of set, they have given you Cartesian product. So that's mean the element which you will assume will be a ordered pair. For example, if we will talk about this, then what we always do in such a type of question for reflexive, we just take a single value. We say that let A belongs to set A. But in this case, we don't have a single set n. If we will talk about this case, then here we do not have n, we have n cross n. So even for reflexive, if we need to assume a value, for example, we say that let small a belongs to this set, then in this case, we can't say that let a belongs to n cross. We can't say this. What we will assume? Anyone can tell me? Let
Let A comma B belongs to n cross.
let a comma b belongs to n cross n. Very good, Atif. This is clear. Huzefa, Noma. Okay, Noma, this clear? Okay, okay. Because in place of set A or set N, they have given N cross N. Okay, that's why we need to select the ordered pair, even for the reflexive. So we have assumed this, let A comma B belongs to N cross N. Okay, so that means we can say that A comma B belongs to N. We have taken the ordered pair because this ordered pair belongs to the Cartesian product. Now these are the two values. First value will belong to n, second also belong to n. So we can say that AB belongs to n. Okay, now please analyze this one. What is the relation? If you have now, normally what we do, we take a ordered pair and we say this belongs to the relation R and we will say that A or B, A is related to B. But in this case, we can't say that A is related to B. We have two ordered pairs. So we need to say this first ordered pair is related with second ordered pair. This is clear, Atif, Huzaifa, and Oma. If you have any doubt, then please let me know. Okay, this is a very, very different type of question. Clear? Atif, Huzaifa, and Oma? This point?
Yes,
Why?
sir.
Okay, Noma and Huzaifa, this clear? Why we have taken two ordered pair? Okay. Okay, now please analyze this relation. What is the relation if you will take a ordered pair? You will take a second ordered pair. Then what is the condition? Take the first element of first ordered pair. Take the last element of the second ordered pair. Then take the second one and then take the third one. This is first, this is fourth, this is second and third. So this is the condition. If we need to prove that this is reflexive, then we need to show that a comma b belongs to, a comma b is related to a comma b. If we need to show that this is reflexive, then we have to show that a comma b related to a comma b. Okay, if this is related, then what we need? We need this condition. What? First element. Josefa, please tell me as per this relation, what is the fourth element? No, but here we do not have D, Josefa. We are proving that this is reflexive. Here we do not, B, very good, is equal to, what is the second element? What is the second element? B. What is the third element? Is very good, A. So we have to find this A plus B is equal to B plus A. Now what here we have done, we have assumed A comma B belongs to n cross n, and we have said that A comma B will belongs to n. This is okay. Now we need this one. So if we will write like this, that A plus B is equal to B plus A, then this is correct, because the same value are there on the left side and same value are there on the right side. So we can say, we have not put any relation. We are just saying that A plus B is equal to B plus A. How you will get to know that we need this one? So in rough, please find out this one. I already told you that in such a type of question, in the starting, you must know that what result you required at time. Okay. So we need this one. That's why we have written A plus B is equal to B plus A, which is correct. LHS and RHS are equal. What is mean by this one? If we will analyze this one, then A plus B is equal to B plus A means A comma B is related with A comma B. Hence, we can say, hence relation R is reflexive. Hence relation R is reflexive. This is clear, Noma, Josefa, and Atif.
Yes, sir.
Okay. Josefa and Noma, please raise your hand if this is clear. Okay, Josefa. Noma, this is clear. Okay, very good. Then next is symmetric. Okay. Next is symmetric. Please try to solve this symmetric. I will give you 1 minute. Please try to solve it and then tell your answer once I will do this one. Okay, Maziha, I guess you might have some internet connection, internet issue. So please check again this question, Maziha. So in this case, we have the set n cross n. Okay, n cross n we have here. What is the relation? A comma B belongs to RC comma D. So first thing, Maziha, normally in a question, the question which we have done till now have only a single set, but here they are saying that you have a Cartesian product. Okay, so in Cartesian product, what is the result? You always get an ordered pair. We have done this in first class, but Cartesian product always give you an ordered pair. That's why in this case, we will assume the value as A comma B. We will not say that A belongs to N, because here the set is Cartesian product. That's why we need the ordered pair. Okay, and please check here, what is the relation here? A comma B related to C comma D. Normally, before this question, we have seen such type of question that A is related to B, because there only a single set is given. But here in this case, they have given the Cartesian product. Okay, that's why A comma B is related to C comma D. Okay, now please check here the relation. Relation is what? If you have two ordered pair, you need to select the first value, you need to select the fourth value, you need to select the second value, you need to select the third value. A plus D is equal to B plus C. So what we have assumed here, we have assumed that A comma B belongs to n cross n, because the set is n cross n. That's why we have assumed the ordered pair. Now A belongs to n, B belongs to n, so we can say that A comma B belongs to n. Now we must know that what we need at the end. We have to prove this one, that A comma B should be related with A comma B. What is mean by this one? Check here the relation. Relation is what? You need first element. Okay, we have written the first one. Then you need the fourth element. Fourth means B. Then you need the second element, that is B. Okay, this one. Then you need the third one. Third means A. So you need this. If we will analyze this part, then LHS and RHS is equal to equal. So we can directly say that A plus B is equal to B plus A. You don't need to show this one. Okay, this you need to do in the rough part. So we can write A plus B is equal to B plus A. Now we can say that A comma B is related to with A comma B, because this is the condition. And this equation satisfies this condition. So we can write this as A comma B related with A comma B. Hence relation R is, we can say it is reflexive. Okay, Mazia, this clear? Mazia, this is clear? Mazia, please reply me on the chat box, okay? Okay, so next is symmetric. So I hope everyone has done this and who can tell me. Noma, please tell me what we need to assume. Let Noma, in this case, what we need to assume. Noma, if you have any doubt, then please let me know. Any doubt, Noma, in this? Noma, yes or no? No reply means you have a doubt. Okay, Josefa, please tell me what we need to assume first. Okay, Josefa, your silence means don't know. Okay, Atif, what we need to assume?
Um, let A, B, C, D belong to N. And
Very good. We will write like this. Let A comma B comma C comma D belongs to N cross N. Okay. In symmetric, we need two values. If we will check our previous question, then here when we prove symmetric part, then we always write like this. Let A comma B belongs to the set A. We write always like this. Okay. But if we will check this question, then we do not have set N, we have the ordered pair. So first value will be A comma B. Second value will be C comma D. Okay, so very good, Atif. Josefa, Mazia, and Noma. This part is clear that we will assume this. Okay, Noma, very good. Josefa. Okay, Mazia, good. Josefa, this is clear. Okay, very good. Okay, then we always write such that in the previous cases, if we will check, then in previous cases we write like this, that A is related with B, or we say that A comma B belongs to R. We write like this. A is related to B or A comma B is related to R. Now, if we will check here, then we have what? A comma B related with C comma D. So we will write like this, let A comma B related with C comma D. Okay, so we have assumed this one, that these two ordered pair belongs to your set, that is a Cartesian product, such that A comma B is related with C comma D. Again, before we do the proof of this, we must know that what the result we need. So anyone can tell me at the end what we require. We have assumed this one, what we need to prove. Anyone can tell me what we need to prove in the end. I'm saying that what we need to prove in the end. In the end, what answer we require?
C comma D is related to A comma B.
Very good, very good. So please remember, in relation and functions, from the question only you will understand that this is a equivalence relation or not. From the question only you can decide. Okay, but the main problem is how to represent our answer. For that, you should know that in the end what result we need. So we have assumed this one. What we need this one, that C comma D related with A comma B. If we will check this expression, A comma B related with C comma D, so we will check the condition. Condition is what? A plus D is equal to B plus C. Okay, if we will check the condition in the question, then it is given a plus d is equal to b plus c. What result we need? We need this. What is mean by this one? First value is c, fourth value is b, then second value is d, third value is a. So we need this result, c plus b is equal to d plus a. Now we have find out this one. We can say that shift this side, b plus c here and b plus d here. Sorry, b plus c here and a plus d here. Please check here, they're still not matching. So what we will do, we will interchange this. In place of b and c, we will write c plus b, a plus d will write d plus a. Now we can say that this implies this one, c comma d related with a comma b. So we need this result. Now we have proof like this. This is clear, Atif, Huzefa, Mazia, and Noma. Please raise your hands.
Yes, sir.
Okay, Huzefa, Maziha, Noma. Okay, Noma, Mazia, good. Okay, Mazia, okay. Okay, so you must know that what the result we required in the end. According to that, you need to shift the LHS and RHS. Okay, but please don't show this part in your answer sheet. Do this in the rough. Okay. Okay, so we get this. Now finally we can say, write the same thing. Okay. Now write the same thing. I do not have the space. Okay. There is some problem with my screen. So I'm just writing over here. So just write the same thing, that this a comma b is related with c comma d. This implies this one, c comma d is related with a comma b. Hence relation R is symmetric. Is symmetric. Okay. So please note down this question and okay, this answer up to symmetric and confirm me, then we will do the transitive part. Please raise your hands once it is done. Okay, Atif, good. Okay, Mazia, very good. No, Noma and Huzefa, this is done. Shall we start next? Okay, Noma, good. Huzefa, shall we start next? Huzefa, this done. Okay, very good. Now next. Just give me a minute, okay? I will again share my screen. Okay. So next, we need to show that this is transitive. Now, anyone can tell me, Noma, can you tell me what we need to assume first? For transitive, what we need to assume? Josefa, can you tell me what we need to assume in transitive? No? Mazia, can you tell me what we need to assume in this one? We need 3 values in this case, okay? So anyone can tell me what we need to assume here? Late? Okay, is very, very good, Josefa. So as we will first of all assume the value, let a comma b, okay, this first value, then b comma c, okay, this is the second value, and third e comma f belongs to n cross n. So we need 3 values. That's why we have assumed this, that a b b c, sorry, y e f. Okay, a b, just give me. So we need 3 values. A b, c d, and e f belongs to n cross n. Okay, this is the first value, this is second value, and this is the third value. We have assumed that this belongs to n cross n. Such that, what we always assume, such that a comma b is related with c comma d, and c comma d is related with e comma f. We have 3 values. First this one, second this, third this. If you will relate this with a previous question, then we assume like this: a, b, c, and we say a comma b, we say b comma c. Okay, and then we prove that a comma c belongs to R. Here, what are the values? The first value is a comma b, second is c comma d, third is e comma f. And we have assumed that first and second values are related, second and third are related. Now from this one, anyone can tell me the expression from this? Who can tell me? Noma. Noma, what is the expression from this? A comma b related with c comma d. Just put this relation. What the answer you will get? Noma, from this, what the answer you will get? Josefa, what the answer you will get from this relation? A comma b related with c comma d. Josefa, if you wish, you can unmute yourself, okay, and can tell the answer. Maziha, can you tell me the answer? A comma b related with c comma d. Atif, can you tell me?
Can you repeat the question?
Yes, we have this relation a comma b related with c comma d. So can you tell me the what expression we will get if we will apply this condition?
A plus C is equal to B plus C.
A plus d is equal to b plus c. Same
Yes,
condition. The values are same. Let this be 1. And from this, what you will get? Please check here. Here we need to take the first value. First value is c. We need to take the fourth value. Fourth is f. We need to take the second value, which is d. We need to take the third value, which is e. So this is 2. Now what we will do, what the result we need at the end, we require this one, first value and third value. We need the relation with first and third. So that means we need a comma b related with e comma f. So for this, what we require, we need put this condition: a plus f is equal to b plus e. We need this one. So anyone can tell me from first and second equation how we will get this result: a plus f is equal to b plus e. Anyone can tell me?
What is, sir?
We need this result: a plus f is equal to b plus c. So from 1 and 2, from 1 and 2, how can we get this result? A plus f is equal to b plus c.
We need to subtract both the equations.
Or we can say we will add 1 and 2. Okay, we will see this. Add 1 and 2. So what you will get here, you have a plus d. Then you will get here c plus f is equal to, in the right side you have b plus c. So on the right side you will get d plus c. Now cancel out the same term. C will cancel out. Then D will also cancel out. So finally you will get A plus F is equal to B plus E. So this implies from this means what? A comma B is related with E comma F. Now we will write the same thing. Thus A comma B related with C comma D and C comma D is related with E comma F. This implies what we get this result. This implies A comma B is related with E comma F. Hence relation R is transitive. Relation R is transitive. This is clear to everyone.
Sir, I subtracted both and also got the same answer.
We're getting the same one.
Yeah,
A,
after subtracting.
but if we will subtract this equation from 1 and 2, if you will subtract, then you will get A plus D minus C minus F. But we need here A plus F. Okay, Atif?
Sir, we can take it as D plus C equal to C plus F. And it'll be the
Okay,
same thing. Then you can subtract in India.
you have interchanged the places.
Yes, sir.
Okay, then it's good. Okay, so Josefa, Mazia, Noma, this is clear. Raise your hand, please. Josefa, Mazia, and Noma, this is clear. Okay, Mazia. Noma and Josefa. Okay, Noma. Josefa, this is clear. Okay, very good. So please note down this. I will give you just 1 minute for this. Then we will find the equivalence class. Okay. Most of the time they ask you for the equivalence class. So we will check how can we find this one. Please note down this question. Okay, and before that, yesterday we have discussed the equivalence class. So who can tell me this? Josefa. Josefa, can you tell me what is the equivalence class? Definition of equivalence class? You can tell me in your own words. Okay, is this done? Shall we start next? Atif, Josefa, Mazia, this is done. Shall we start next?
Yes, sir.
Okay, Josefa, Mazia, and Noma, this done. Okay, Josefa, okay, Mazia, Noma, this done. Okay, Noma, very good. So equivalent class is a very important topic. Okay, we have discussed this yesterday. Now they are saying find the equivalent class, this one. What is mean by equivalence class, first of all? So please write the definition. Equivalence class this one 2 comma 3 is a set of all those elements in n cross n. Okay, equivalence class, this one is a set of all those elements in this set which are related with 2 comma 3 which are related with this under the relation R. Under the relation R. Okay, so what is mean by equivalence class of this? This means you need to find all the elements which are related with 2 comma 3 under the relation R. Okay, so in such a case, just follow this method. First of all, assume a value. Let x comma y belongs to your given set. So here the given set is n cross n, such that x comma y is related with 2 comma 3. Just write like this. So you need the value x comma y. Okay, and this x comma y is related with this 2 comma 3. Now this means what? So x comma y related with 2 comma 3 means what? Just put the condition which is given in the question. So condition is a plus d. So that means x plus 3 is equal to b plus c. So y plus 2. So from this, what you will get x minus y. Just shift this term to the left side, 2 minus 3. So this means x minus y is equal to minus 1. So we get this condition, x minus y is equal to minus 1. So you need to select the ordered pair. Now we will select the ordered pair. Okay, we will select this ordered pair. So we need to select this ordered pair such that when you will subtract both the terms, you should get minus 1 and both the values should belong to the natural number. So anyone can tell me the first ordered pair?
1, 2.
1 comma 2. Very good. Now next question is from Noma. Noma, first is 1 comma 2. Then what is the second ordered pair? Why we have selected 1 comma 2? If you will subtract x minus y, 1 minus 2, you will get a minus 1. So Noma, can you tell me the second value? Very good. Noma, 4 comma 5. Okay, but before that we will take 2 comma 3. We will go in sequence. 2 comma 3. We can say 3 comma 4. We can say 4 comma 5. Okay, we can say 5 comma 6 and so on, because this is a set of natural numbers, so the terms will be infinite. So we can say equivalence class of what this one 2 comma 3 is what is the equivalent class? Write the complete order here. 1 comma 2, 2 comma 3, 3 comma 4, 3 comma 4 and so on. This is clear. Atif, Huzefa, Mazia and Noma, how to find a equivalence class?
Yes.
Okay, please raise your hand. Huzefa, Mazia and Noma. Okay, Noma. Okay, Mazia. Huzefa, this clear? Huzefa, this clear? Okay, so from last some years, they ask question from this equivalence class. So what you need to do, just assume a value from the set and just write that this value is related with your element. Put the condition, find the ordered pair from the set which satisfy this condition. Okay, so please note down this. We have completed 2 questions. Now the rest of 3 questions you can do on your own. They are the same type of questions. So this week, please try those 3 questions. And if you have any doubt, we will discuss in the next class, but hopefully you can do that. Okay, so please complete those questions. Okay, so please complete this. Let me know, then we will again start the functions. Raise your hands once it is done. Okay, Atif, very good. Josefa, Mazia, Noma, please confirm. Okay, Mazia, very good. Josefa, Noma, this is done. Josefa and Noma, please confirm once it is done. Okay, Noma, very good. Josefa. Okay, Josefa, very good. Now we will start the next one. Okay, so this question is your homework. Okay, Mazia, I'm not sure you were present in the class or not. So please take a screenshot of this. Noma, please take the screenshot. Yesterday I've given 5 questions in homework, 2 we have done. Please try these questions. Okay, Mazia and Noma, please take the screenshot of this. Shall we start next? Mazia and Noma, okay. Okay, Noma, very good. Just give me a minute. Okay, please take the screenshot of this also. This is also a homework. This done. Atif, Mazia and Noma, this done. Sorry, Joseph, Mazia and Noma. Will we start next? Please take the screenshot of this also. Okay, so these are very important question. In all the questions, you need to find the equivalence class. Okay, I will check on next Saturday this. Okay, so next is we have started the functions yesterday. Okay, so this is the same thing which you have done in class 11th. So just take a screenshot of this. I will explain to you later on that what is meant by function. Okay, Mazia and Noma, you both were absent yesterday, so please take a screenshot of this. Please let me know once it is done so that I can explain you this. Okay, Noma, good. Mazia, oh, okay, you were there. Okay, so then it's good. So Noma, last year you have already done the functions. Okay, I will again repeat that. We have this set. We have next set B. Okay, then a relation from set A to set B is called a function if suppose we have these values A1, A2, A3, B1, B2, B3. So we will do the definition in 2 steps as we have done last year. All the elements of set A should be associated to elements of set B. So that means all the elements which are present here in set A should be associated, should be linked with the elements of set B. That means if you have an element like this, which is not linked with any of the element, then this is not a function. Okay, so the first condition is all the elements should be associated. Second is all the elements should be associated to a unique element. So that means A1 should be linked with a B1 only a single element. If this is the case that A1 is also related with next other element, then this is not a function. This is not a function. Okay, but if this is the case that you have a A4 and it is also linked with B3, then this is a function because all the values are related with a single element only. So what is a function? Where all the elements are associated of set A are associated to elements of set B and they are associated to a unique element. So this we have already done in last year. Okay, no more. Now, what is a domain, codomain? Now, if f is a function from A to B, then the complete set A is called the domain of f. Complete set A is called the domain of f, and complete set B is called the codomain of f. Set A domain, set B codomain. What is the range? The images of elements of set A. So if you will take the previous case, then here A1 is linked with B1. So B1, B2, B3, these are the range of this function. Okay, so what are the range? This one, the elements, we can say the image of A1, A2, A3, and A4 are the range of the function. Okay. Okay, next is kinds of functions. So this is of the class 12. So we will do this topic in detail. Okay, and Noma, if you wish, you can check the yesterday's lecture. Okay, I have done the function in detail. Now we will start the kind of functions. First is one function. This is also called the injection. Okay, please don't write now. Please don't note this right now. Now, what is a one function? A function f from A to B. So I hope you understood what is mean by this symbol. F is a function from A to B. So that means you have two sets, set A, and you have another set, set B. Okay, you have another set B. So a function from set A to set B is said to be a one function if different elements of A have different images in B. So what does this mean? This means if you have the elements, for example, A1, A2, A3, and here you have the elements B1, B2, B3, and suppose you have a B4, then different elements have different images. So A1 is linked with B1, A2 is linked with B2, A3 is associated with B3. So here you have a different elements A1, A2, A3, and they are associated with different element of B1, B2, and B3. So this is a one function. Clear? Atif, Huzefa, Mazia, and Noma. This clear?
Yes, sir.
Okay. Okay, Noma. Huzefa and Mazia, this is clear? 1-1. Okay, Mazia, very good. Huzefa, this clear? Okay, very good. Then please tell me this question, Mazia. Suppose we have this set A and we have another set B. Okay. Here we have A1, A2, A3. Here we have B1, B2, and B3. Now suppose A1 is linked with B1, A2 is linked with B2, A3 is linked with B3, and here we have a B4. Oh, and here we have A4. So Mazia, this is a 1-1 function or not? Mazia, this is a 1-1 function or not? Mazia, please reply me on the chat box, yes or no. Mazia, yes or no? Okay, Noma, this is a 1-1 function or not? Okay. Josefa, this is a 1-1 function or not? Very good. Josefa, what is the reason? You can unmute yourself, Josefa. What is the reason? Yes. If you will check this case, then A4 is not related with B4, so this is not a function. Okay, this is not a function. A4 is not related with B4. If this is not a function, that's why it can't be a 1-1 function. Okay, so this is not a function. Now next one. Next question is from Noma. Noma, suppose we have a set this A. So this is not. We have another set B. Here we have the value A1, A2, A3. Here we have the value B1, B2, B3. A1 is associated with B1, A2 with B2, A3 with B2. So Noma, can you tell me that this is a 1-1 function or not? No, very good. What is the reason, Noma? Noma, what is the reason why this is not a 1-1 function? Because A2 and A3 have the same image. Very good. Okay. As per the definition, different elements should have a different image. But if you will see here, then A2 and A3 have the same image. That's why this is not a function. Sorry, this is not a 1-1 function. Now, next question is from Atif. Atif, suppose we have this set A, we have another set B. Okay, so this is also not a 1-1 function. We have A1, A2, A3. And here we have a B1, B2, B3, and B4. So A1 is associated with this. A1 is also associated with B2, B3, and this one. So Atif, this is a 1-1 function or not?
No,
No. Why?
because A1 is associated with two elements.
Yes. So this is not a function. This is not a function. That's why this can't be a 1-1 function. Okay. So please remember, for 1-1 function, first thing, it should be a function. So you need to check the definition of function. We have 2 points for that. Secondly, you need to check that different elements should be associated to different elements. Okay, so A1 should be associated with different, A2 with different, A3 with different. In that case, we will say that this is a 1-1 function. So I hope this is clear to everyone. You can note down this example. Okay, this is example of 1-1 function. Please note down this definition and this example and confirm me. Then we will start the second topic, that is a many-one function. But always remember, we are doing the kind of function. So for any of the kind, the given relation should be a function first. So please check the definition first of all about the function. If that satisfies the definition, then only we can decide that this is a which type of function. Please raise your hand if you have completed this. Okay, Atif. Good. Josefa, Mazia, and Noma, please raise your hand if this is done. Okay, Mazia, very good. Okay, Josefa, good. Okay, very good, Noma. Now next one. Now next our topic is many one function. Okay, many one is the opposite of one one. What is one one? Different element should have different images. So what is the opposite of this? There can be one or two elements which have the same image. So please check the definition. A function f from a to b. Okay, again the same symbol. So you understood this. What is meant by this one? A function f from a to b is said to be a many one function if two or more elements of set a have the same image in b. So what does this mean? Suppose we have taken the first set, this is as a, we have taken the second set as b, we have a1, a2, a3. Okay, suppose we have b1, b2, b3, and let this be b4. Suppose a1 is associated with b1, a2 with b2, and a3 is also linked with b2. So here two elements have the same image, that's why this is many one. So the opposite of one one is many one. Okay, in one one you have a different image for different elements. In many one you have same image for one or two elements. Now, so this question is from Josefa. Josefa, please tell me that this is many one or not. This is A, this is B, this is A1, A2, A3, this is B1, B2, B3, and B4. So A1 is linked with this, A1 is linked with this, A2 with this one, A3 with this one. So Zephyr, please tell me, this is many one function or not? Okay, Noma, this is many one or not? Okay, good. Mazia, this is many one or not? Very good, Josefa. Now it's correct. Okay, Mazia. Atif, please reply me on the chat box. This is many one or not? Atif, please reply me on the chat box. Very good, Atif. Josefa, will you please tell us the reason why this is not many one? Because each has different images. No, Josefa, this is not the right reason. Atif, will you please tell us the reason why this is not many one?
Because A1 is related to two elements, so it is not a function.
Very good. This is not a function. Okay, please remember, first of all, you need to check that the given question is a function or not. After that, you need to check this is a which kind of function. So if we will check here, then A1 have two images. What is our second definition? We have discussed this thing in detail yesterday. We have done 2 points. First is all elements of set A should be associated, and elements of set A is associated to a unique element. Okay, so this second condition is not getting satisfied in this question. Please check here. A1 is associated with two elements, so this is not correct. A1 is not associated with a unique element. It is associated with two elements, which is not possible in a function. So this is not a function. If this is not a function, then this is not many one. Okay, so first of all, please check the definition of function. Now next question. Next question is from Noma. This is set A, this is set B. We have A1, A2, A3, and A4. Here we have B1, B2, B3. A1 is linked with this, A2 is also linked with this, A3 is linked with this one. So Noma, please tell me, this is a many one or not? Okay. Josefa, this is anyone or not? Please reply me on the chat box. Mazia, please reply me on the chat box. Atif, reply on the chat box, please. This is a anyone or not? Good, Atif. Josefa, Mazia, please reply. This is a anyone function or not? Okay, Noma, now it is good. Okay, Mazia. Josefa, what is the answer? Josefa, what is the answer? Very good. So, Josefa, what is the reason why this is not a anyone function? Josefa, what is the reason? Please check here. This is not a function. A4 is not associated with any element. That's why this is not a function. If this is not a function, you can't say that this is anyone. So first of all, please check that the given relation is a function or not. Please again revise all the definitions. Okay, this is A and this is set B. We have the element A1, A2, A3, and we have this element B1, B2, B3, and B4. A1 is linked with B1, A2 with B1, and A3 with B1. Okay, everyone please reply me on the chat box. This is a anyone function or not? Okay, Atif, good, this is correct. Zephyr, Mazia, and Noma, very good, Noma, this is correct. Zephyr and Mazia, please reply. Okay, Mazia, very good. Zephyr, please reply me on the chat box. Okay, Zephyr, very good. So yes, you are correct. This is a anyone function. Okay, so please note down the definition and then raise your hand so that we can start the next one. Okay, I will erase all this. Please note down the definition. Note down one example. And raise your hands once it is done so that we can start the next step. You can note down this example for this type of function. Everyone, please confirm Atif, Zephyr, Mazia, Noma. If this is done, please. Oh, okay, Noma. Okay, Atif, good. Zephyr and Mazia, please raise your hand if this is done. Okay, Mazia, very good. Zephyr. Zephyr, please raise your hand if this is done. Okay, very, very good. Now next one. Next, third is onto function. Okay, so third is onto function, which is also called the surjection. So please remember these names also, because sometime in exam they just give this name. They check whether this is a surjection or not. Okay, most of the time what students do, they just learn this name, onto function. But in exam they ask you from this name also. So please remember all the names. Okay, for example, this one function is also called injection. So learn this name also. This onto is also called surjection. So please remember this name also. Now we will check the definition. Again, the same symbol, you know this, a function f from a to b is said to be an onto function or a surjection if every element of b is the f image of some element of a. So what does this mean? This means suppose you have a set A, you have another set B. Okay, this is A1, this is A2, this is A3, let just be A4. Suppose this is B1, this is B2, this is B3. Suppose A1 is associated with B1, A2 with B2, A3 with also B2, and A4 with B3. So you need to check this set B. There should not be any element in set B which do not have its pre-image in set A. So in other words, in a simple words, you can say there should not be any elements in B which is not linked with which do not have the pre-images in set A. So if you will check a previous case, okay, so for example, if we have this one, again the same thing, but this should be a function. So you need to check first that it satisfies the condition of function or not. So we have if this set A1, A2, A3, and A4, and we have another set B1, B2, and B3, and B4. B4. Suppose A1 is associated with B1, A2 with B2, A3 with B3, and A4 with B3. Now, if you will check here, then B4 do not have its pre-image in A. That's why this is not a onto function. Okay, so for onto function, all the elements here should have their pre-images. This is clear, Atif, Huzefa, Mazia, and Numa. This definition is clear for onto function. Please raise your hand if this is
So
clear.
does this mean in onto functions, codomain is equal to range?
Yes, we can say. That's good. Good.
Okay, sir.
Huzefa, Mazia, and Noma, this is clear. Huzefa, Mazia, and Noma, this is clear. Okay, Mazia, good. Please raise your hands. Noma and Huzefa. Okay, Noma. Huzefa, this is clear. Huzefa, this is clear. Huzefa. Okay, very good. Okay, so please remember for onto function, all the elements inside B should have their pre-images. So this is one question. This is A, this is B. And Mazia, this question for you that we have A1, A2, A3, and A4. Here we have the element B1. A1 is linked with B1, A2 with B1, A3 with B1, and A4 with B1. So Mazia, can you tell me that this is a onto function or not? Very good. Noma, Huzefa, Atif, please reply me on the chat box. This is a onto function or not? Good, Noma. This is correct. Good, Atif. Huzefa, this is a onto function or not? Huzefa, Huzefa, yes or no? Okay, Huzefa, very, very good. Okay. So yes, this is also onto function. So please note down the definition of onto function and you can note down any of these examples. Okay. Then please raise your hand if this is done. Then we will start the next type, which is an into function, which is just opposite of onto function. So please note down this. Everyone, please raise your hand if this is done. Okay, Atif, very good. Okay, Noma, good. Zephyr and Mazia, please confirm if this is done. Zephyr and Mazia, this is done. Shall we start next? Mazia and Josefa, shall we start next? Okay, Josefa. Okay, now next one. Next is into function. If anyone miss anything, then please let me know. I will change the slide. Okay. Next is an into function. What is into? It is just opposite of onto function. Okay. So what happened in onto function? That in set B, you should not have any element which do not have its pre-images in set A. Now, what happened in into function? Here you have A1, A2, A3 and A4. And in B, you have B1, B2, B3 and B4. Okay. So this is A1, this is linked with this is with B2, and suppose this is with B3. So if we have any element which do not have its pre-image, then this become an into function. Okay, we will check the definition. A function from A to B is an into function if there exists an element in B having no pre-image in it. Okay, so there can be present one or more elements in set B which do not have its pre-image. Or you can learn in this way, it is the opposite of onto function. Okay, so what happened in onto? All the elements in set B have the pre-images in set A. In into function, there can be one or two elements. Okay, this is clear. Please raise your hands. Atif, Zephyr, Mazia, and Noma. Please, okay, Atif. Zephyr, Mazia, and Noma. Okay, Noma, good. Zephyr and Mazia, this is clear. Zephyr, okay, Zephyr, good. Mazia, please reply. This is clear. And everyone, please note down this. Okay, then confirm me. Then we will solve some questions based on these topics. Please raise your hand if this is done. Then we will start the questions. Okay, Noma, very good. Atif, Zephyr, Mazia, please confirm. Okay, Atif, good. Zephyr and Mazia, please confirm if this is clear. Zephyr, I got. Zephyr, this is done. Shall we start next? Okay, good. Okay, then we have one more type, bijection, which is 1, 1 onto. What does this mean? If a function is both 1, 1 and onto. Just if a function is both 1, 1 and onto, then we will say that this is bijection. You already know that what is 1, 1. You know that what is onto. If a function is both 1, 1 and onto, then we will say that this is bijection function. Okay, please note down this, confirm me, then we will start some questions on the basis of this topic. Okay, please complete this. Please raise your hand if this is done, then we will start the questions. Everyone, please raise your hand if this is done. Atif, Huzefa, Mazia, Noma, this done. Shall we start next? Okay, Atif. Okay, Noma. Huzefa, this done. Huzefa, raise your hand if this is done. Huzefa and Mazia. Okay, Huzefa. Now next one. Next question based on 1 function. Okay, so this is the first question. First is f. I will show you the second also. So we need to complete these two questions. So the question is, first question is f r2r given by fx is equal to x cube plus 2 for all x belongs to r. We have this function. We have this function, and this is in place of set A you have r, in place of set B you have r. So Josefa, what is r in this case? Josefa, what is r in this case? Real numbers. Okay, so here both the sets are real number, and this is given fx is equal to x cube plus 2. So we know we need to show that this is 1 function. Okay, so please check here how we need to show. In for 1 function we approach like this. First thing, always remember, as I already told you in relation, that if you need to prove that something is false, if you need to prove that this is not 1, then just give a simple example. If we need to prove that it is false, we will give an example. But here we need to prove that this is, we need to check first of all, this is 1 or not. So how we will approach, let two values x1 comma x2 belongs to R from the first set. Okay, we need to assume the value from the first set. Now here both the sets are given, so we might get confused. So we will write in the bracket, let x1 comma x2 belongs to R. What is R? Domain of the function. Domain of f. Because both the sets are same, we will get confused in the question. That's why we have written here that domain of f. First, this is the first step. You need to assume x1 comma x2 belongs to R, such that after this you need to prove that you need to put like this, fx1 is equal to fx2. First of all, assume the value in the first set, then put fx1 is equal to fx2. Now Atif, can you tell me, if this is the function, then what is the value of fx1?
x1 cube plus 2.
Very, very good. Okay, so fx1 is equal to x1 cube plus 2. This we have already discussed, I think in determinants, that if function is given, you need to find any value, then in place of x, you need to put that value. So fx1 is equal to x1 cube plus 2. What is fx2? Josefa. Josefa, what is fx2? Josefa, you can unmute yourself. Okay, we need to complete some questions and we have just 20 minutes. Very, very good. Josefa, this is correct. So this is x2 cube plus 2. Now what will happen? This 2 we can cancel out. So what we will get, x1 cube is equal to x2 cube. Okay. And from this, if x1 cube is equal to x2 cube, then we can say that x1 is equal to x2. Okay. If cube are equal, then we can say x1 is equal to x2. If x1 square is equal to x2 square, then we can't say that x1 is equal to x2. We will say x1 is equal to plus minus x2. Always remember, if you have the even power, then you need to put plus minus sign. If you have an odd power, then you can say, yes, these two are equal. Please remember this. Okay. So in 1, what you need to do, first of all, you will assume a value from the first set. You will put fx1 is equal to fx2, and you will show that if you are getting this x1 is equal to x2, then you can say that the given function is 1, 1. Hence, the given function, hence, the given function is 1, 1, is 1, 1. Okay. So in 1, 1, what you need to do, first of all, assume the value, put fx1 is equal to fx2, then apply the operation. If you are getting x1 is equal to x2, then you will say that the function is 1, 1. If you are getting two values, for example, if you are getting x1 is equal to plus minus x2, then you will say that this is not 1, 1. If you are getting equal value, x1 is equal to x2, then we will say this is 1, 1. If we are getting two values, then we will say that this is not 1, 1. This is clear. Please raise your hand. Atif, Huzefa, Mazia, and Noma. Please raise your hand if this is clear. Okay, Atif. Huzefa, Mazia, and Noma, this is clear. Okay, Noma, great. Huzefa and Mazia, this is clear. Please raise your hands. Huzefa and Mazia, this is clear. Okay, very good. Okay, I hope Mazia this is also clear to you. So please note down this and then start in the same way the second part. Okay, please tell me the second part that this is 1, 1 or not. Atif, very good. This is clear. This is correct. Josefa, Mazia, and Noma, please do the second part. Okay, and confirm your answer. And if you have any doubt in the second part, then please let me know. Okay, so Atif has completed the second part. Please check here for the second. Josefa, Mazia, can you tell me the second part? This is 1, 1 or not? We will assume two values. Let x1, comma x2 belongs to z. Okay, such that. Okay, z means what, Josefa? Josefa, z is integer. Okay, so fx1 is equal to fx2. Then what is mean by fx1? X1 square plus 1 is equal to x2 square plus 1. 1 will cancel out, so you will get x1 square is equal to x2 square. Now this is a even power, so you will get x1 is equal to plus minus x2. So you are getting two values. If we will get two values, then we will say function f is not 1, 1. Is not 1, 1. Okay, and this question we can also do in by giving an example. So suppose you have two sets. This is set A, you have another set, this is set B. If you will take the value 1, then what you will get from this function, fx is equal to x squared plus 1. So f1 will be equal to 1 plus 1, which will give you 2. Sorry, yes, that's correct. There's 2. So 1 will be associated with 2. If you will put minus 1, then what you will get, f minus 1 will give you minus 1 square plus 1. This will again give you 2. So minus 1 will also give you 2. So 1 and minus 1 have the same image. That's sorry, 1 and minus 1 have the same image. That's why this is not 1, 1. So if in the starting of the question you can show this, you understood that this is not 1, 1, then you can just give a simple example. Okay. Now one question, Atif, if we will replace this sorry, so if we will replace this z by n, okay, then Atif, this will be a 1, 1 or not?
It will be on one function.
Then it will be on 1, 1. Okay, because if this is a natural number, then we will not put any negative number here. Then it will be a 1, 1. So you need to check both the things, the function as well as the set. There is an integer, that's why there is a possibility of that we will put a negative number. Okay, so I hope this is clear. So please note down this, Atif, Huzefa and Mazia, and confirm me, then we will start some more questions on the basis of same topics. Please raise your hand if this is done so that we can start next. Atif, Huzefa, Mazia, this done. Shall we start next? Atif, this done.
Yes.
Okay, Huzefa, this done. Huzefa, shall we start next? Huzefa, this done. Okay, okay, Huzefa, very good. So next, this one. On to we will discuss later on. Okay. These questions are based on onto, but we'll do this later on. Okay, now Huzefa, what is a bijective function? Huzefa, what is a bijective function? Atif, what is a bijective function?
Function which is both one function and one function.
1 1 and 1 on 2. Okay, but this question, in this question you need to show both, but right now we have not started on 2. So for write this, just write this question. So here you need to show that this is not 1 1. So I already told you that if you need to show that this is false, just give an example. Okay, just give an example. We will not apply the complete method. Just give an example and show that this is not 1. Okay, please do this question. Please raise your hands, okay, if this is done. This is done. Atif, Atif, this is done. Okay, okay. Please check here. Here the function is from n to n, that is from natural number to natural number. This is the last question, then we will over our class. So this is n and this is n. Okay. Now here we will write all the natural numbers. Now what they are saying here, that if you will write 1, 2, 3, 4, 5, here you will also get the natural number 1, 2, 3, and so on. Here what they are saying, if you will put 1 in the function, you will get a 1. So that means 1 will be associated with 1. If you will put 2 in the function, you will again get 1. So 2 is also associated with 1. So this is not 1, 1. So this means what? That fx is equal to 1 when x is equal to 1 and 2. If you will put the value 1 and 2, you will get a 1. But if you will put any value which is greater than equal to 2, then you will get a x minus 1. Okay. So this is given. So what we can write? We can write f1 is equal to 1, f2 is equal to 1, hence 1 and 2, hence 1 and 2 have the same image, so the function f is not not 1 1. This is clear? Atif, Josefa, Atif and Josefa, this is clear?
Yes.
Okay, Josefa, this clear? Josefa, this is clear? Okay, very good. So note down this, then we will end our class. Now, your homework is assignment 2. Okay, homework is assignment 2. So we will upload the assignment 2 shortly. Then you need to complete this plus 3 questions from the relations, okay, which I have given yesterday. And please revise the complete chapter. This is a very difficult chapter, so please revise it. Okay. Okay, then if you have noted down this, then we can end our class. Okay. You can drop off if you have completed this.